Welcome to Math Science History. Today, we're taking a journey through time and measurement to discover the history of the metric system. Hi, I'm Gabrielle Burchak. I have a background in math, science, and journalism, and today we're going to hear a story with revolutionaries, globe-trotting scientists, and even a touch of drama. In the year 415, the infamous philosopher and mathematician Hypatia of Alexandria, Egypt, was savagely murdered by church monks. This murder shocked the Roman community and its government leaders. Hypatia was known far and wide as a respected philosopher, mathematician, government advisor, and a professor. Hypatia, The Sum of Her Life, is a book that I wrote that looks not just at the circumstances surrounding her death, but also at the sum of her entire life. I weave in the details of her education, disciples, Neoplatonic philosophies, female contemporaries, and the many mathematics that she wrote and taught about. There is truly more to Hypatia's life than her death. Hypatia, The Sum of Her Life, written by me, Gabrielle Burchak, is now on sale on Amazon. Buy your copy today. The metric system was born from an idealistic vision at the height of the French Revolution, a vision of measurement termed by Marquis de Concorde as for all people, for all time. In this episode, we'll explore how a team of French scientists set out to redefine everything by measuring the Earth itself. We'll meet heroes like Jean-Baptiste Delambre and Pierre Méchain, who braved perilous adventures to pin down the length of a meter and the weight of a kilogram. We will see how people initially resisted the strange new system, old habits do die hard, and how it eventually conquered the world. So grab your kilogram of snacks, or I could say 2.2 pounds for some of you, and let's hit the road. We're going to travel back in time to the late 18th century France. It's 1789 in Paris. The French Revolution is in full swing. Heads are rolling, literally. Ideas of liberty and reason are electrifying the air, and nothing is off limits for reform. Amid this upheaval, one very practical problem stood out: weights and measures. Every region, every trade in France seemed to have its own units. A pied, which is also known as a foot, in one town could be a different length than a foot in the next town. Length, weight, and volume measures were incompatible across France. This chaotic patchwork made trade and taxation a nightmare. Imagine buying fabric where an L, E-L-L, is a different length depending on which city you're in, or a farmer being cheated because his bushel isn't the same size as the merchant's bushel. With their love of rationality, the revolutionaries were determined to fix this. So, enter the French National Assembly, which in 1790 decided that France, and hopefully the rest of the world, needed a completely new measurement system, one logical, universal, and based on nature. They officially commissioned the prestigious French Academy of Sciences to figure it out. The politicians said, "Hey, scientists, give us a system of measures that will be the same everywhere and make it so good that we can say it's for all people, for all time." No pressure there, right? A panel of 5 of France's brightest minds was appointed to tackle this in 1790. These were the names for the ages: mathematician Gaspard Monge, astronomer Pierre-Simon Laplace, the great Joseph Louis Lagrange, thinker Nicolas de Concorde, and naval scientist Jean-Charles Desbordes. This is quite the dream team of Enlightenment science. Over the next year, they debated how to create the perfect measurement system, and they produced some guiding principles that still define the metric system today. The decimal base. In the decimal base, everything should scale by tens. No more 12 inches in a foot, no more 3 feet in a yard, no more 16 ounces in a pound. Instead, units would neatly multiply or divide by 10. It's easy for calculations. The natural units. The unit of length should come from nature, specifically from the size of the Earth itself. They decided that the primary unit of length, the meter, would be defined as 1/10 million of the distance from the North Pole to the equator, along the meridian line running through Paris. In other words, take a quarter of the Earth's meridian and chop it into 10 million equal pieces. One piece is a meter. This was a bold idea, literally measuring the Earth to define a unit. For weight, they said, let's use water as a reference. And the unit of mass should be the mass of a cube of water of a specific size, since water is something everyone can access. Then there is universal names and prefixes. This process even produced a naming scheme using Latin and Greek roots for different scales. For example, kilo meant 1,000. Centi was for 1/100th, milli for 1/1000th, etc., etc. So you could easily tell how big or small a unit was. A kilometer is 1,000 meters, a millimeter is 1/1000th of a meter, and so on. So it's much more straightforward than, say, 5,280 feet in a mile or 14 pounds in a stone. The French National Assembly loved these proposals and formally approved this plan in 1791. Now, they had to measure that meridian arc accurately and make the prototype meter and kilogram. Simple? Right. It's not that simple. Okay, so to define the meter, they had to get a precise measurement of the distance from the pole to the equator. Of course, they couldn't measure the whole quarter meridian, but they could measure a representative chunk of it and extrapolate. So they decided to measure the distance along the Paris meridian from Dunkirk, France, to the North Sea, all the way south to Barcelona, Spain. This stretch covered a good swath of the Earth's curvature. So, who drew the short straw for this assignment? Well, it was two astronomer surveyors, Jean-Baptiste Delambre and Pierre Méchain. In 1792, Delambre and Méchain set out to survey this meridian arc through painstaking triangulation. It turned into a 6-year odyssey full of challenges. Remember, France in the 1790s was a bit unstable. The Reign of Terror was underway. France was at war with multiple European powers. It's not exactly a relaxing time for a road trip across the countryside with strange scientific instruments. Delambre headed northward from Paris toward Dunkirk, and Méchain went south toward Barcelona. They used high-precision instruments to measure angles between landmarks, which were like church spires, hilltops, to create triangles across the land, a method to calculate distances. They carefully measured baseline distances using rods and then figured out the rest trigonometrically, all while dodging literal and figurative bullets. So I guess the revolution was a bad time to be a mathematician. Local villagers and troops often had no idea what these gentlemen were doing. Imagine two guys lugging giant brass instruments, climbing towers, and sending flashes of light or waving flags across the hills. In that climate, people suspected they might be spies or up to no good. There's an anecdote that Delambre was chased, harassed, and even thrown in jail by local authorities who thought his triangulation equipment was some kind of espionage toolkit. Delambre wrote letters back to Paris desperately saying, "Please send help. People keep arresting me or breaking my instruments." So it was that kind of a trip. Méchain, working in Spanish Catalonia, faced his own woes. At one point, the war between France and Spain halted his progress. Méchain was also a perfectionist and became obsessed with an anomaly he detected in his measurements near Barcelona. He kept remeasuring the latitude of Barcelona's location because it didn't precisely match what he expected. This quest for perfect accuracy would haunt him. He even hid some data because he doubted it. Nevertheless, by 1798, more than 6 grueling years in the field, Delambre and Méchain finally completed their survey and returned to Paris as scientific heroes. One can only imagine the scene. They come back, weather-beaten and exhausted, but carrying notebooks filled with numbers that hold the key to the new meter. Using their data, the calculated length of the meter was finalized in 1799. It turned out to be remarkably close to what we now know today, about 39.37 of our current inches long. If you want the exact figure, the meter was defined then as 443.296 lignes in Old French units, but we will stick to modern terms.
We'll be right back after a quick word from my advertisers.
To make the meter's definition real, they cast a metal prototype bar. In June 1799, a bar of platinum was made to embody the new meter, which they called the Meter of the Archives. They stored it in Paris as a reference. Likewise, for mass, they made a platinum cylinder to represent the kilogram, defined as the mass of a liter of water at the temperature of melting ice. This kilogram prototype, known as the Kilogram of the Archives, was about 3.5 centimeters tall and wide. It was a fancy, shiny weight that was supposed to equal the heft of 1 liter of water. These two objects, the meter bar and the kilogram cylinder of 1799, became the physical standards for the new system. The scientists were optimistic and even utopian about their creation. The metric system was touted with the motto, "For all people, for all time." They truly hoped it would be adopted worldwide and last forever, since it was based on the Earth's size. Little did they know, the Earth isn't a perfect sphere. There were slight flattenings at the poles, which meant their calculations had tiny errors. So, remember Méchain's obsessive remeasuring? He had found a slight discrepancy in the data. It turned out their defined meter was ever so slightly off because Earth is not a perfect sphere. It was a very minute difference on the order of a fraction of a millimeter. Still, it weighed on poor Méchain so much that he reportedly confessed it only on his deathbed. What a weight to carry, pun intended. Luckily, this tiny error was not enough to derail the project. As they defined it, the meter was close enough for government work, and the metric system was officially born in France in 1795, with the final standards in place by 1799. By 1800, France had a new, incredibly logical system of measurement. But if there's one thing we humans love as much as a good idea, it's not letting go of old habits. It turns out that convincing everyday citizens and merchants to adopt the metric system was almost as challenging as the geodetic expedition itself. The French government introduced the metric system as the law of the land in 1795, making it the official system of weights and measures. However, the implementation was poorly managed by modern standards. They had to educate an entire nation, much of it illiterate, about new units with unfamiliar names. The government printed thousands of pamphlets explaining the new measures. They even produced many physical meter sticks to distribute. But it wasn't enough. Paris alone needed 500,000 meter sticks to supply all the shopkeepers and citizens. Only a few tens of thousands were ready in time. Common folk were understandably confused and skeptical. Imagine one day you're told the arpent and toise you have used forever are no more, and now you must use meters and liters based on some arc of the earth you've never seen. The metric units had no reference point in people's daily experience yet. It probably felt like abstract gibberish to a farmer or a baker. And amid the turmoil of the revolution, which was not exactly a calm time to introduce bureaucratic changes, people had bigger worries, like surviving. As a result, the metric system initially met a lot of resistance and even outright noncompliance. Many folks kept right on using the old familiar units in markets and homes, ignoring the new laws as long as they could. Enter Napoleon Bonaparte, the famous general who became ruler of France. Napoleon inherited this metric system project when he took power. And guess what? He wasn't a fan at first either. He reportedly ridiculed the metric system for being too complicated and inconvenient for ordinary people. Napoleon, who was busy conquering half of Europe, probably didn't have patience for people complaining about how many centimeters were in a meter. As a pragmatic leader, he recognized the value of a uniform system. Still, he also saw the populace hated the abrupt change. So, in 1812, Napoleon made a strategic retreat on enforcement. He introduced the customary measures, essentially a compromise allowing the old unit names back into day-to-day commerce, but slyly redefined in terms of the metric system. For example, he brought back the livre, the old French pound, so bakers could go on selling a pound of bread. But officially, 1 livre was now 500 grams. The old pied, the measurement of a foot, was allowed again, defined as 1/3 of a meter. People could still use their familiar words, while under the hood, France was still metric. This half measure eased the transition. Even after Napoleon fell from power, France returned fully to the proper metric system by 1840, making the use of those old names for metric units illegal and reaffirming that only the metric units were official. It took decades, but eventually, the French public got used to meters and kilograms. By the mid-19th century, France was solidly metric in law and practice. Beyond France, Napoleon's armies had swept across Europe. In the process, they introduced the metric system to conquered territories in the early 1800s. Some places, like parts of Italy, the Low Countries, and Germany, adopted it under the French rule. After Napoleon's defeat, a few reverted to the old ways for a time, but the seed was planted. Over the 19th century, one country after another saw the appeal of a universal system. Portugal was actually an early adopter in 1814, which is actually surprising since it wasn't under French occupation. Latin American countries, many newly independent in the mid-1800s, like Chile, adopted the metric system. Italy and Germany found the metric system useful during their national unifications in the 1860s. It was a neutral, modern system that helped unify regional differences. By 1875, the metric system's success led to a landmark international agreement, the Treaty of the Meter. 17 nations, including significant powers like Britain, the US, Germany, and of course France, signed this treaty to cooperate in maintaining standard measures. They established the International Bureau of Weights and Measures, which was sort of a metric headquarters to keep the prototype meter and kilogram and oversee comparisons. This treaty made the metric system a truly global concern, even if some countries were slow to implement it at home. Notably, Great Britain, the inventor of the rival imperial system, was a tough nut. The British hesitated to adopt that French system for a long time. National pride dies hard. Yep, it does. British industry and trade were deeply invested in their own units. The United Kingdom only officially began metrication in the late 20th century, and today it still uses a mix of measurements, like pints of beer and miles on road signs. However, science and engineering industries use the metric system. And the United States? Why is the U.S. still not fully metric? The U.S. participated in the 1875 Treaty of the Meter and even adopted laws in 1866, making it legal to use the metric system. American scientists and industries use metrics extensively. However, the U.S. never mandated metric for everyday use. Pounds, inches, and gallons remained king culturally. There was a push in the 1970s to metricate, but it fizzled out. Today, America stands almost alone in clinging to customary units in daily life, along with only a couple other countries that haven't fully converted. For years, Myanmar and Liberia were the other two holdouts, though they've also expressed intent to go metric. Still, even Americans deal with metric units more than we realize, with 2-liter soda bottles, 100-meter dashes, and 5K runs. By the 20th century, the metric system had grown from a revolutionary French idea into the world's standard for science and international trade. Nearly all countries have adopted it officially, at least for commerce and science. It truly lived up to being a system for all people, not just the French. But what about for all time? Well, to answer that, we need to see how the metric system evolved over time to become even more precise and robust. The metric system, now known as the International System of Units, the SI, is the silent backbone of our high-tech world. From space travel to AI and digital infrastructure, it's the universal language that keeps global systems aligned. One of the most infamous reminders of why standardization matters came in 1999 when NASA lost the Mars Climate Orbiter due to a mix-up between imperial and metric units. It was a $125 million mistake. Today, agencies like NASA, the ESA, and others rely on metric standards to ensure compatibility and precision. From oxygen levels during spacewalks to bolt sizes on the International Space Station, everything is measured in meters, liters, and kilograms to make international collaboration possible. The metric system enables seamless data integration in artificial intelligence and global science. Whether it's climate data or medical research, using kelvins, pascals, and milligrams eliminates the confusion of conversion errors. AI systems in medicine, robotics, and autonomous vehicles rely on sensors that measure in metric units, making it easier for technologies made in different countries to work together. Even computer chips are manufactured with nanometer precision. Emerging tech like quantum computing and neural networks depend on measurements grounded in microkelvins and metric-defined constants. Beyond science, the digital economy and everyday life are steeped in metric logic. Bitcoin uses denominations like millibitcoin and microbitcoin, mirroring SI prefixes. Internet speeds are measured in megabits per second, hard drives in gigabytes, and global timekeeping runs on the SI second, synchronizing satellites, servers, and financial systems worldwide. The metric system, once envisioned during the French Revolution, has become an enduring framework that supports everything from Mars landings to the data powering your smartphone. Its clarity, consistency, and universality continue to unite our increasingly interconnected world. The history of the metric system is more than a story of measurements. It's a story of human ambition, reason, and the pursuit of unity. So, world peace might just be possible. Born out of a revolution and Enlightenment ideals, it set out to create a system for all people, for all time. Remarkably, it succeeded. From the perilous expeditions of Delambre and Méchain to today's quantum-referenced definitions, the metric system has evolved into a global foundation for science, technology, and communication. It reminds us that shared standards can foster collaboration and progress, even in a divided world. So, whether you're calculating a recipe, launching a satellite, or decoding a genome, you are part of a legacy that began with a bold idea. The entire world could agree on how to measure it. Until next time, carpe diem.
Thank you for tuning in to Math Science History. If you enjoyed today's episode, please leave a quick rating and review. They really help the podcast. You can find our transcripts at mathsciencehistory.com. And while you're there, remember to click on that coffee button because every dollar you donate supports a portion of our production costs and keeps our educational website free. Again, thank you for tuning in. And until next time, carpe diem.